There's two things that we can get from a mitotic crossover, and while we don't really understand the full entire mechanism of it, we can make observations about it, and we can make conclusions based off of those observations of it. So the two results that we can get from a mitotic crossover, crossing over that happens during mitosis, this is really rare, but it does happen. DNA is DNA, and it does its thing, it does its reactions. So we can get twin spots, and then we can get these things called single spots. So twin spots, the result of this is that we have a mitotic crossover. So I'm just going to say mitotic crossing over that happens between the centromere, if I could write, between the centromere and the genes. So if we have a crossing over taking place between those two regions, depending on the gene of interest, that's what it's going to give us. This is just big picture type stuff, exam coming up, prepping for it. So what are we going to observe for this? Well, we get the wild type here. Here's a patch of, say that this is, I don't know, in Drosophila skin. I know. And then there's two patches here. There's a patch there, and then there's a patch there. So there's a mutation there, and then there's a mutation there. These are not reflective of the wild type phenotype. And this depends on the number, obviously. If you have more than one or whatever, you can have more than one twin spot. But single spots, I'll switch colors to a yellow. For single spots, what happens is, this is when we have a mitotic, I'm just going to say mitotic crossing over happening between the genes themselves. There is no centromere location to deal with. And what this results in, so say you have wild type here, well, inside of it, you're going to have just one mutant area.